Right, guys, I've checked that calculation. The difference between what I had looked at previously was just simply the rounding error. So please make sure that you've got the electricity sorted out, EMF questions, and internal resistance. That was a fairly straightforward one, but it is important that you recap that. And I know some of you might not have done enough revision on circuits because it was done in grade 11. Don't forget capacitors as well. Okay, another very popular question is the question around Doppler effect. So let's go and have a look at this Doppler effect question, which is also taken from the Gauteng paper, and we are told the following. A police car with a siren is traveling quite quickly. It's traveling at 33 meters per second on a straight road as it approaches a stationary truck. The siren of the police car has a frequency of 3001 hertz, high frequency. Take the speed of sound as 330 meters per second. Now, the first part of the question says explain the Doppler effect in words. So you have to put this into your own words. There's not a statement that you need to learn, but you need to have some crucial information that you're going to explain to the examiner. So what is the Doppler effect all about? And in fact, we did a little description of the Doppler effect from the KZN prelim earlier in the show, but basically what we're saying is that the Doppler effect is the apparent change in frequency or pitch that an observer experiences when a source is moving. Okay, source emitting the sound or light or even water waves is moving either towards or away from it. So that's the idea that we need to have. Remember for your studying, you know that when an object is stationary and something's moving towards it, the apparent frequency is going to be greater. When it's moving away, the apparent frequency is going to be less. Okay, let's move on. We want to get the calculation done, so we're jumping right to that one. It now says, calculate the frequency of the sound heard by the driver as the police car approaches it. Now, it's really not a difficult question to deal with, because we're given the formula from the data sheet. The formula of the listener or the observer is equal to, it just looks difficult, plus or minus the listener, observer, over the frequency plus or minus the source, times the frequency of the source. So make sure that you've got the understanding of what this formula is all about. There's the apparent frequency, the frequency observed. There's the actual frequency. What you've got to do is to decide what's happening to this ratio in the middle. Now, what we know is that the truck is stationary. So the first thing that I need to recognize, the truck is stationary. That means that the listener velocity is 0. The second thing I've been told the velocity of the sound, and I know the frequency over there. So in this case, I can actually start to do some substitutions. But before I do substitutions, I want to make sure that I've got the right sign. And my decision about sign is if it's moving towards, then the observed frequency is going to be bigger than the frequency of the source. So that's what I need. And if I want it bigger, then what I need to make sure is that the numerator is going to, or the denominator has to be smaller than the numerator. This one is 0, so that means I need a minus on the bottom. So I'm going to rewrite that in that reasoning. So here I go. I'm going to say it's V, because this is plus or minus 0, and over here I'm going to say it's V minus the frequency of the source times VF. V source, sorry, not VF. Now let's substitute our values in, and we're going to work it out. So we know that the velocity was 330 plus or minus 0. This one was 330 minus the speed of the car. The velocity of the traveling was 33. The original frequency was 3001. So 3001 hertz. Now, I'm going to calculate this part first, because I want you to see that 330 divided by this fraction, 330 minus 33, is going to be, let's do it again, just got a syntax error, divided by, in my brackets, 330 minus 33, close my brackets, equals, there we are, 10 over 9. Hope you can see that's a fraction that's bigger than 1. Check it, 1,11. So now we have to check ourselves. We're going to say, if we've got 1,11 times 3001, what do we expect? If you multiply something by 1, it's going to give you the same. But multiply it by 111, that's 0,111, it's going to get bigger. And that's exactly what we're going to see here. We're going to multiply this by 3001. And what do we get? We get an answer of 3,334,44. So let's write that down. Check your answer, write it down, and then we're going to do the check step. 3,334, comma 44. And two decimal places, 44 is fine. So we're going to write it 44 hertz. Okay, now, is that realistic? Well, yes, because we know the truck was moving towards. So the observed frequency has to be bigger, and we've substituted our values in, and we know, therefore, that that looks like the right answer. Okay, let's quickly take a look at what the second part of this question. How will the frequency of the sound heard by the driver of the truck change after the police car passes the truck and moves away from the truck? Right only increases, decreases, remains the same, and explains your answer. So guys, now the truck, the car passes the truck. It's moving away after the driver changed, after the truck passes. So it's moved away. And what we need to recognize is if it's now moving away, the frequency is going to do what? It's going to decrease. So decrease, the reason that it decreases is that we recognize now that there is the wavelengths increase. The wavelengths increase. In other words, let me put it to you this way. As it's moving towards, the frequency bunches up. Over here behind the moving source. The source is moving that way. It's moving towards the observer. This is the listener. It's bunching up. If it's moving away, what happens behind the source? It's got time to spread out. So the wavelengths increase, and so the frequency decreases. And so we will hear a lower pitch. A lower pitch. Okay, frequency decreases. And that's exactly what we wanted to hear. What will the frequency of the sound heard? And we've got it sorted out. There is one last question which I want to deal on this paper. Write down one application of the Doppler effect in medicine. Now, the main one here is to measure blood flow. Okay? Measure blood flow, and you can also measure babies or the heartbeat. The heartbeat of an unborn baby. Okay? The baby's moving inside its mom. Sometimes they can use the Doppler effect using the ultrasound, and it's all about this medicine blood flow. You've got movement source, they bounce it off the moving particle, and we can then calculate the rate of flow. Now, guys, I'm really sorry. We've almost come to the end of this session. It's been great being with you. We've just highlighted some mechanics, some electricity, and some Doppler as the main sections that we wanted to revise from prelim questions. I hope that if you've got any other questions, please don't forget, you can send your questions to the help desk. We might not be able to answer them on our live show, but we will get you the answer no matter what. So please email to helpdesk@learnextra.co.za, and that's right up until the time that you write. And we're getting busy, we're getting teachers to email you back your responses, particularly from questions that you're struggling with. Now, also remember that next week we're going to be doing paper 2. So get your questions in early. The earlier we've got your questions, the more questions we can answer that you would like to answer. You can post those questions to helpdesk as well at learnextra.co.za. You can leave a phone message at the call center number 086 1058-262 during the week. We will pick up those phone messages as well. You can also post them on Facebook and get in touch with us that way. Now, don't go away, because right up after I've finished here, we've got Kathy waiting by to help you with Life Sciences Paper 1. We've got 2 prelim papers to look at, the GDE prelim as well as questions from the KZN prelim. If you've got any other prelim questions, you want some detailed explanation, give us a call. That number to dial 086 1058-262. Okay, remember, go for it. You're our champions. We're supporting you. Class of 2011. We're expecting great things from you. So we're here to help you. We're here to support you. Let's make sure that you get the best marks you possibly can. From myself, John, thanks to the team that's been behind the scenes, and we'll see you again next week. Bye for now.